So we take a look at number 1. In your practice, we are going to find the inverse or graph the inverse of each function and then answer the questions in the box. Okay, so if we look at number 1, we have a table. To find the inverse of this table, all you have to do is just switch the x and the y, because that's what happens when you find the inverse. So all the x values are going to go in the y column, and all the y values are going to go in the x column. So my new x values are going to be negative 75, negative 39, negative 15, and positive 15. And my new y values are going to be negative 10, negative 4, 0, and 5. When we enter in the box, the domain of the original table, that's all the x values. So the domain of the original table, we're going to write it in set builder notation, because it's just a list of numbers. It's negative 10, negative 4, 0, and 5. That's the domain. The range is all the y values. So again, write it in set builder, because it's a list of numbers. It's negative 75, negative 39, negative 15, and positive 15. Is it a function? Yes, the original is a function. No x values repeat. So yes, it is a function. Well, for the inverse, the domain is the same as the range of the original, right? The x and y values switch, so the domain and ranges switch. So the domain is whatever the range was from the original graph, except instead of putting y, we put x because it's the domain. But the numbers are still the same. It's going to be negative 75, negative 39, negative 15, and positive 15. And if we look, those are the new x values. The range is the same as the domain of the original table. But we're finding range, so we need to put a y. So the the range of our new table is negative 10, negative 4, 0, and 5. It's whatever the domain of the original graph was. Again, when you find the inverse, the domain and the range switch. And if you look at the table, the range is all the y values, which is negative 10, negative 4, 0, and 5. And this is also a function because none of the x values repeat. If we take a look at 2, we are going to find the inverse of problem 2, and again, it might be helpful. Write down the points. So this first point is at negative 2, negative 3. The next point is at 0, negative 2. The next point is at 2, negative 1. The next point is at 4, 0. And the last point's at 6, 1. And then when we find the inverse, you just flip the points. So our inverse points are going to be the ones that are in green. So you just flip the original points. Don't need to change the signs or anything. You just flip. And then plot your new points. So we're going to plot negative 3, negative 2, negative 2, 0, negative 1, 2, 0, 4, and 1, 6. And connect. They're not drawn there, but technically there's arrows on this graph as well. Okay. So for our domain of the original graph, it's a linear function, so it's going to be from negative infinity to positive infinity. Same thing for the range. It's from negative infinity to positive infinity. The x-intercept of the original, I meant to keep that color coordinated. The x-intercept of the original graph was 4, 0. And the y-intercept of the original graph, sorry about that, was 0, -2. Well, everything switches with the domain and the range. So for the inverse, the domain is whatever the range is of the original. Well, that happens to be negative infinity and positive infinity. The range is whatever the domain of the original is. They switch. They both just happen to be negative infinity to positive infinity. The x-intercept switches. So wherever the x-intercept is of the inverse, it's the same as the y-intercept, except we write the x number first. So the x-intercept is 0, -2. That's true if we look at our graph. The y-intercept is 0, 4. And again, that's true if we look at our graph. We want to plot the line y equals x. So when we do that, start at the origin, and then you just go up 1, right 1, or down 1, left 1. And if your graphs look like they reflect over that orange line, then you know you graphed it correctly. And if we take a look at number 3, we want to find the inverse. Again, write down the original points. So we have -2, 0, -1, -3, 0, -4, 1, -3, and 2, 0. Okay. So when we find the inverse, just flip the points. So we have 0, -2, -3, -1, -4, 0, -3, 1, and 0, 2. Okay. And plot your new points. So you have 0, -2. We have -3, -1. We have -4, 0. -3, positive 1. Something seems off. Oh. Hold on. I'm sorry. Let me replot these. I feel like something's off here. So our original was -2, 0, -1, -3. And then when we flip, okay, so when we plot our points, we have 0, -2, that's what was off. And then -3, -1, -4, 0, there we go. -3, positive 1, and 0, 2. So there's the inverse in purple. So the domain of the original, there's an arrow on the left, arrow on the right, that's going from negative infinity to positive infinity. The range for the original, the lowest it goes is -4. Then we have those arrows on the top, so it's going from -4 to infinity. This has two x-intercepts. One of them is -2, 0, and the other one is +2, 0. One x-intercept, the other x-intercept. The y-intercept is right there. It is 0, -4. For the inverse, again, everything switches. So for the inverse, the domain is the same as the range of the original. -4 to infinity. If we look, yep, on the left we start at -4, We have arrows on the right towards infinity. The range is whatever the domain is of the original. So our range is going to be from negative infinity to positive infinity. If we look at our graph, arrow on the bottom, arrow on the top, that range is true. And our intercepts change. So for our x-intercept, it's going to be same as the y-intercept. So that our x-intercept is going to be -4. This time around, and if we check, if we look at our graph, yep, my x-intercept is -4. Our y-intercepts also change. So my y-intercept is whatever the x-intercept is of the original. So our original had 2 x-intercepts, so our inverse is going to have 2 y-intercepts. So one is going to be -2, the other one's going to be +2. And if we look on our graph, one y-intercept's at -2, one y-intercept is at +2. If you notice, the original graph was a function, and our inverse is not a function. When we graph the lines y equals x, and I just plot that line, start at the origin, go up 1 over 1. I feel like there's a lot going on my graph here, sorry. But these do reflect over that line. It might not look like it because there's a lot of highlighting going on. But when we graph that line, they do reflect over that line, as it says to do in the top there. So there you go, there's the first 3.